Okay, I have to help somebody else. And then we start. You make this strange noise again, right?
Okay.
Okay, so welcome here at 903. We give a remedial in quantitative skills. The thing I want to achieve with you is that you lose your fear of numbers. Because many people here at ISS, they have not been educated properly. And what you will also see is that numbers can be as important as words. Very often you have to understand the language of numbers in a debate. And that are the kind of things that we are going to do here during class. So, your remedial is organized as follows. The first lecture, that's today, I will talk about basic operations. It's like very technical things, like adding up, summing, subtracting, multiplication, roots, powers. Then the second lecture will be about proportions and percentages, which is also a topic which students often find very difficult. And then we move on to the average and the frequency distribution. And finally, we will talk about tables, about graphs, about exponential growth, which actually requires us to use logarithms. But I could also tell this story differently. I could also tell you that this first course will be about how the Egyptians do their adding up, about what is wrong in education in Suriname, and how we can do better. I could tell you about the second lecture. That will be about why are we missing globally 100 million girls? Or it's about where do the global poor live? Because they don't live in low-income countries anymore. And like this fourth lecture on exponential growth, it's actually about global warming and about the environment. And you can see that there are many topics from developing studies which require numbers, right? That's the reason that I give the review. I also don't want you to go back with the diploma from ISS and be afraid of people who use numbers. Because we will see that if you're a little bit, if you put a little bit effort in it, that you should not be afraid of numbers. Now the way we test the numbers is by a test. And you've all made this test. And you failed the test. And I can tell you one thing that happens. It also happens sometimes with people who became professor later on, right? I also missed my test, so there's no problem there. But we also want you to make it with the next test. And that's the reason that we're going to have first the lectures on the principles, and then we will redo the test with you, and we will help you and train you, show you how you attack a problem like the things that are being asked from you, right? And there I will be helped with by Eri. Eri is a PhD student here at ISS. She's in the back. Eri, you should stand up. Everybody can see you. Eri is not allowed to give you the questions that were asked. She will show you in the presentation the questions that were asked, and then she will talk to you and with you and see how you can solve these things. And I'm going to tell you one secret, one of her secrets, one of her perfect advices. Read the question. Because very often people don't read the question. And I know this for certain. Because I have 3 daughters, and my oldest daughter, she is in pharmacy, and she was very good in numbers because, well, she's my daughter, right? So she's good in numbers. What happens? She comes at university, she has to do a test. She thinks, well, this is an easy test. It's about numbers. She fails. I think it's good for her. Right. So I ask her, how is it possible? And then she tells me she didn't read the question. So that's one of the first things. Stay calm, read the question. And for the rest, it is like we know from previous years that most students, after the remedial and the hands-on exercises, are perfectly capable of passing this test. Perhaps 1 or 2 or 3 will fail, and they will get a special exercise, a specially designed exercise, and they will have to talk with me about numbers, about population. The exam is set for November 25, so you have a full week of preparation, but you can start to do the preparation now, because books in the library, there are also all kinds of online tests, and you can simply try. And you will see that during the lectures, I will sometimes stop. Then it's a yellow sign. It means there is an exercise. This is where you have to wake up, right? And then you have to do the exercise. I have 3 rules. What to expect today first. I'm going to talk to you about types of variables, about arithmetic and algebraic operations, about numbers, about fractions, like a quarter or a third, about rounding, why is 1.25 rounded to 1.3, and about powers and roots. And I have 3 rules. The first rule is a very important rule. You can only learn from your mistakes. Right? The second rule is there are no stupid questions. Not that I exist, never. When I'm teaching, there are no stupid questions. Every question that you might want to ask, you will get an answer. And it's a gift. It's not only a gift to me, because you will allow me to be more explicit, to explain things better, but also to your students. Because if you have a question, you can be then sure that there is also somebody else with a question. So the only stupid thing that you can do is, if you have a question and you don't ask it. And I'm not in a hurry, right? I'm a relaxed person. If we need more time to discuss something, I will take the time. There's no problem. Now the first thing I have to talk to you about is that there are different kinds of numbers. And the reason that I talk to you about that there are different kinds of numbers is because it is important that you're able to recognize these numbers. So the first thing that we have is numerical variables or quantitative variables. It's a property of an individual or an object that can be expressed in terms of a positive or a negative number. An integral, or a decimal. An integral is like 1, 2, 3, 4. It's a whole number. A decimal is like a fraction, a quarter, 0.3. So that's important, because there are many things that we can observe. You're female, you're male. It's not a number. Once I start to count, how many female are in the room? 1, 2, 3. Now I give it a number. And then we have continuous variables, and they can take any value. So it can be very small, it can be very large, but it can be any value. It's like length. You can be 1 meter 96, 1 meter 97, 1 meter 97 and 2 millimeters. See, that's continuous. Weight, income, and for example the acres of land. And then we have discrete variables. So that's not continuous, it's still numerical, but it is not continuous. It can take a limited set of numerical values. Like, how many kids are there in your family? 3. I can't have 3.5. Still, if I go to the office of the Central Bureau of Statistics in the Netherlands,
and I ask how many children are there in a family, they will say on average 2.5. So I have to cut one of my daughters in half, right? See? An average can be continuous, but the observations can only be 0, 1, 2, 3, 4, 5. And then we have the categorical variables. They are qualitative or descriptive. They are not numbers. They describe a quality. Sometimes we can order them. And you all know, when you have ever done a survey, you know that there can be ordering. Like fully disagree, disagree, no opinion, agree, fully disagree. See? There is an ordering. If I start at one side, it's very logical how the answers go, right? So there's an ordering. But it's a quality, because this is about something on which you have an opinion. I can't count opinions. How many opinions are there? I have 2, right? Because I'm an economist. You always have 2 opinions, on the one hand, on the other hand. And then we have nominal variables, and they don't have an ordering. It's like gender. You can't say male, female is more logical than female, male. Or countries. The ordering of the countries. Very often you see that the ordering of the countries is by alphabet, so that looks like that there is a logic in it. But I come from a country, the Netherlands, and if I'm in the Netherlands or in England, it starts with an N, but as soon as I go to France, it will be Pays-Bas, so then it's a P. And I know this because I've been in a lot of international meetings. I always had to check where I had to go. Some cases I would be next to Norway, other cases I would be next to Poland. See, there is no order which is logical. So these are the variables, and we can take a look how they look in real life. Very often you will get a table. And this is a table about the years just before the financial crisis, the start of the financial crisis. This is February 2010, June 2010 to December 2010. And this is about, if you take a look at the title of the table, it's about countries that experienced the largest increases in the prices of the main food staples. And you can see the main food staples over here. Maize, wheat, beans, rice. You see that there are many locations. Now already I have to start talking to you for a minute about this table. It's a very bad table. It's a table from the World Bank. It's a professionally made table, but it is a difficult table to understand. You can see that there are percentage increases, but it does not tell you a lot, right? What does it mean to you that wheat increases by 13.6 and rice by 14.1? So you will have to take a look at this table. Here I have wheat, and you can see that in Pakistan, in the first period, it increased by 24%, and here it increases by 14%. You see that I'm rounding the number to keep it easy for myself to say. Now here, I have Kazakhstan and Bangladesh, and you can see that the increase for the same product is much larger over here than over here. And if I had to say a little bit more about this table, then I only would like to compare Pakistan, India and Bangladesh, because they are close to each other, right? But something happens in Kyrgyzstan completely out of the question. See, now we're trying to make sense of a table. We're trying to understand what the table tells us. And it's a bad table, right? So you can do better. And that's what we will do in the final lecture of this course. What is this? Is this qualitative, quantitative data? Sorry? Qualitative data. Is there an ordering? Yeah, so it's ordinal. See, you can recognize that this, you can go out and you can tell your friends that you now can do this. What is this? This is a question. Do you know what you have to fill in the question? What should be here? A number, right? What percentage? So it should say 10, 50. So this is numerical data, right? A little bit further down the line, in the same questionnaire, there is the issue of, did the categories of requests from your constituencies or partners change since 2006? This is a questionnaire for an NGO who works in the field. And here you see that there are issues identified, and now you also see that there is large increase, moderate increase, remains at the 2006 level, moderate decrease, and a large decrease. So this is ordered data. And in order to help you, they say, give you an indication what they would say. A large increase, more than 30%. A moderate increase, less than 30%. This is also a very bad question. Why? What happens if you are 30? What do you have to answer? See? Now these are the arithmetic and the algebraic operations. And I'll simply repeat this with you. You all know this, but that we have the same language. First we have addition, sum plus. 2 plus 2 is 4. Subtraction, minus. 4 minus 3 is 1. Multiplication can be an asterisk, a point, or a cross. 2 times 3 is 6. Then we have division. Division is like a stroke, or this sign, or it can also be one number, a stroke, and another sign. That's the division, that is the basic operation. 10 divided by 5 is 2. Raising to the power. That means you have to multiply the same number again and again and again. 2 to the power 3, that's 2 times 2 times 2. 1, 2, 3. And we all know 2 times 2 is 4. 2 times 4 is 8. And that's the root. The root of 9 is 3. It's the number that we have to multiply with itself to get at the number which is below the root. The root of 16 is 4. Why? 4 times 4 is 16. So this is like spelling, right? So that we know that we use the same symbols. Now this is Atjoni in Suriname. And you can see it's a school. You can see that the school, this is where they are teaching geography. It's outside the school, right? Because it's a nice climate in Suriname. This is the river, Suriname River. I was on a boat, I saw the school, I wanted to go in. And there I did the discovery that the teachers in Suriname are not doing the right kind of teaching when it's about mathematics. And this is one of the explanations why students sometimes have difficulty, because the teachers have not done the right kind of thing. So let's take a look at this one. See what happens here. What is the answer to this question? 5? Everybody agrees? 11. So the people in Suriname indeed will work like 4 plus 3 is 7, 12 minus 7 is 5. Okay? But that's not okay. Because adding up and subtracting is like an elevator. You are on the 12th floor, you go down 4, and then you go up 3. So you're at 11. This one. Is the answer to this one the same as the answer to this one? Who says yes? Who says no? We will see. 12 divided by 4 is 3. 3 times 3 is 9. 12 divided by 3 is 4. 4 times 4 is 16. Many people think 12 divided by 12 is 1. Right? Don't feel stupid. Really don't feel stupid. It's really very bad that this happens. And the reason, I will tell you the reason very soon. Next one. Yeah, is the first one the same as the second one?
Yes.
It is. But it is not 0, right? 1 times 0 is 0. Plus 1 is 1. Plus 1 is 2. Plus 1 is 3. Plus 1 is 4. 0 times 1 is 0. Plus 1 is 1. Plus 1 is 1. Plus 1 is 2. Plus 1 is 3. Plus 1 is 4. Right?
Good move, I guess.
It's 4. Okay?
The first one.
And this one? 1 times 0 is 0, right? 1 plus 1 plus 1 plus 1. 4. Let's take a look why this is. Right? I'm first going to show you what is the good rule. Okay? And then I'm going to show you why. So, this is the way you have to do it. If there is a big mathematical explanation, we start with everything which is in parentheses. So that's why the first letter is PEMA, P-E-M-A, right? First we do parentheses and brackets. Second thing is, we do exponents and roots. Then we are with the M. Now take a look. It says multiplication and division, because multiplication and division, I will explain you very soon, it's the same. It should be done at the same level. You don't give the order to one of them, because they're equal. And then we have the A, addition and subtraction. And you can always remember it. You will never forget it. Peter, me, eats many apples. Right? Peter eats many apples. And this is not the same as what people have been taught. It's called PEMDAS, and there is a saying to remember it. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. This has been taken literally by many teachers, and they require that all their pupils, all their students, do this in this order. So first, you do parentheses and exponentials and roots, and then you do first the multiplication and then the division. Then you get the same sort of problem that I showed you, right? And then the addition and the extraction and the summation, that's also suggesting that it needs to be done in this order. Wrong. Completely wrong. In Suriname, I talked about this at the Ministry of Economic Education, and there are people who know that this is a problem, and they are trying to convince the teachers' union that they should start to teach differently. But why is it that these things are wrong and this is the right kind? First I want to show you how it works. Yes, there, sir.
I have a question back.
Back?
The slide.
There we are for you.
In Uganda, we are told to use Bormas.
Bormas. And what does it mean?
It means brackets.
Yeah.
Which I think is
That's the
correct.
same, yeah?
I have forgotten O,
Yeah?
but D is division,
Yeah?
and then M is multiplication,
Yeah?
then addition,
Yeah.
and subtraction.
Okay, sir. You can remember it. But you also have to remember that it is wrong, right? Because it does not have to be done in this specific sequence, right? We here in the Netherlands, we have Meneer Van Dalen wacht op antwoord, which is actually the Dutch translation of this, but it is like what you have, right? And at my school, they were also teaching this the wrong way. So now let's first take a look at what does this mean with present tense and things like this. So this is Washington DuPont circle. So that's in the United States. That's where I bought the shoes, right? These shoes, bought over there. You can't really see it, but over here, let's switch off the light for a moment. Can you see it?
Yes.
Next to the traffic light, it says 35 degrees, right?
Yes.
If it's here in the Netherlands, 35 degrees, then we go to the beach. You will see me in my shorts, but over there it's not 35 degrees, it's not like. It's because they have Fahrenheit. And this is the formula for Fahrenheit, right? It says 5 over 9, which means 5 divided by 9. The temperature in Fahrenheit minus 32, which is awfully complicated, but it is the temperature, right? This is a ratio, or a fraction, and that's the formula. So there we go. What is the temperature in Celsius in Washington, D.C.? So now I substitute the 35. It's the same equation, right? That's what I substitute. Now I have to do the calculation. Peter eats many apples, so I start within the parentheses. 35 minus 32, that's 3. So I have 5 divided by 9 times 3. Well, we will do the fractions a little bit later. The 3 times 5, 9. It's 15, 9, right? It's more than 1. It's 1/6. Or, to write it completely different and more easy, 1/2. Or, so that you understand what this really means, right? So now we have used this principle and we have used the formula. And formulas are like this. You start to put in the numbers and then you do it step by step. And then it's easy. Let's do first an exercise. Ooh. Yes. I'm sorry? The 35. When they took out the light, there we go. Oh, I have to take out the light. See over here? The 35? It's like a thermometer. It's there. And they show the temperature all day. So that's where the 35 comes from. But this is in the United States, so it's Fahrenheit. It's not Celsius. Okay? So you understand where it comes from? There we go, with the exercise. You see it's yellow. It means wake up. You have to do something. Step by step. There we go. First within the parentheses, right? And now we have to take a look inside the parentheses. This is the first one. This is adding up. This is an exponential. So this is the first thing I do. 2 to the power 3, 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. That's where the number comes from. This is not in parentheses, so I write it down. Just take it down. Then I have this one. I didn't do anything about it because I want to show you later on. And this is also the same. So, right? Because now I go to the next step. Back. Sir,
Yeah, I understood something.
you have understood it?
Yeah.
No problem there. Okay. So now multiply and divide. That's over here. 16 divided by 2. It's 8. I'm not doing anything here with the minus 1 because that's subtracting. Over here I have 8 times 3. That's something which I do, right? That's my next step, 24. I also still have this over here. And I'm working within the brackets. And now I'm going to add and subtract within the brackets because I'm first working in the brackets, in the parentheses. Right? So I have here 10 plus 24, that's 34. Plus 4 to the power 3. I don't do anything because it's not in the brackets. 8 minus 1, that's 7. Times 5 minus 150 divided by 5 to the power 2. So now I got rid of my parentheses, right? That was the first thing I did. All the calculations within the parentheses. Once I'm in the parentheses, first the exponentials, then multiply and divide, then add and subtract. Next, E and A. There we go. First the exponentials. What are the exponentials over here? This one and this one. So that's the first step that I do. 4 to the power 3. 4 times 4 is 16, times 4 is 64. 5 to the power 2. 5 times 5 is 25. So here I have 64, here I have 25. Next time, multiplication and division. 7 times 5 is 150 divided by 25 is 6. 34 plus 64 minus 35 minus 6, that's 57. 34 plus 64, 98, minus 41, 57. It's a recipe. It's like when you start to cook, right? If you simply throw in everything, all the food stuff in the pan, it won't taste good. You have to do this in the proper sequence. Okay? Now this is Egypt, Luxor, and it's a bit difficult for you to see, but because I want to show you something, right? This is me, and this is my guide. So this is in a very big temple in Luxor, and that's where the pharaohs lived. This is 1400 before Christ, so that's long ago, right? Nobody of you was born then. And she tells me about this. I told her that I was an economist. She said, well, there is something interesting at the back of the temple, and it looks like something which economists are interested in. Numbers. Okay, let's see. What number would this be?
1.
What number would this be?
2.
This one. 6, right? They don't write it like us. Can somebody guess what this is?
Minus 1.
10. Okay? This one over here, 100. They also have a frog. It means 1,000, but it's not here. So she says to me, well, this is a table, but the interesting thing is it's not complete. Because well, you can see that they have not finished everything, right? No numbers everywhere. So I take a look, I say, you're wrong. They didn't have a 0. Okay. This is strange, right? This is 3,000, more than, this is 3,500 years ago. And somehow we can see that people were counting and that they were, this is like a table. Because I can't read the stuff over there. But there's a guy here at the university, John Steenwinkel, and he is learning the hieroglyphs at the moment. You can put on the light. And he told me that this is about offerings to the gods. And they simply wrote it down, right? And that's why it's in the temple. How many goats were killed? How many people were killed? How many? So I'm there and I'm thinking about how did this Tutankhamun add up? And you can see, well, we saw it, right? This is the 6, and they will put on ones until they are there at 10. And this sign is like a person who walks, it means add up. Right? So this is 1, 2, 3, 4, 5, 6 plus 1, 2, 3, 4, 5, 6, 7, 8. So that's 14, right? 6 plus. Take it out, it still is 14, right? You can also write it like this. This is the way they write. Easier to recognize, but it is like this. Now, my question is, does it matter if you calculate what's on top or what's at the bottom? So with the I8 to the right or with the 8 to the left? Does it matter? No, it doesn't matter because it's all the time, it's like 14, right? 14. So this is very important because this means that you now have discovered something where the mathematicians have a name. It's the commutative law of addition. It says if you add m plus n, then it's the same as n plus n. Why do they make it difficult? They need to have a living. If they tell you that it is this easy, they won't have a job, right? But you see why this is the case, right? And now you understand it. And it's not a difficult thing to understand. Now let's do this one. Over here it says 3 plus 26 plus 30. 30 plus 26 is 56. 59, right? Everybody with me? 59. See 59? This is how they wrote it. 1, 2, 3, 1, 2, 3. 3 over here, 6 over here. Why is that? Because it's beautiful, right? It's a temple. They want to make something beautiful. See that it doesn't matter. This could be on top, this could be at the bottom. It's again the cumulative law. Does the sequence matter? No. We have again also a next law, and it says, this is the associate law of addition, and it says if I have n plus n between brackets, this is what I do first, and then I go to k, I add k, like this plus this, and I add this, or I do these two, and then I add this one. It always gives the same number. The sequence doesn't matter. If I first add up these two and then this one, it's the same number as when I add them up all three. Well, you see, this is how I became professor, right? Selling something which is really easy is something which is difficult. And there it is. And here you can see that's the total. So you see it's there. And I recognized it because I was very much trained in recognizing tables, right? This is also why I could say, yes, but these blanks are zeros. Now over here something extraordinary is happening. Over here there is a big number Lots of circles that mean hundreds and only zeros. And then I think perhaps they have added up all the numbers that were here. Now that's an exercise we're not going to do today, right? Because that's a lot of work. But it's true. And this is something which we always do with tables. And then we also add up this. But the Egyptians didn't do it. And I think that I understand why. They wanted to be able to report how many offerings had been there in a year. But they didn't want to say, this was a cow, this was a human being, this was a goat. They simply added up all the offerings, right? And that's the number which is open. And when you look at the table will have a heading. It will have a column and a second column. This is exactly the way it is done in Egypt. And there will be a heading. It says, what is this column about? And then there will be numbers over here. And you add it up. And this is a simple table, right? Because I only have 2 rows. You could also have 15 rows and 40 columns. The table that I showed you from Egypt, 7 columns. Each column, if you add up, will give you the column total. Now what is the nice thing? You can also add up the row. So then you add up horizontally. And again you get numbers. And then when you add up this, it gives you the grand total. And when you add up this, it also gives you the grand total. Why is this number the same? Because it does not matter how you add up the numbers. If you go from the top to the bottom and then from left to right, it must give you the same as when you go from the left to right and then from the top to the bottom. So you can also add up this, gives you the grand total, and we have again the first 2 laws. See? 2 plus 3 is 3 plus 2. 2 plus 3 plus 6, it's the same. 5 plus 6, it's the same as 2 plus 3 plus 6, 2 plus 9, or 5 plus 6, or 2 plus 9, or 2 plus 3 plus 6, it's always 11. Go from the top, go from the left, doesn't matter. The same is true for multiplication. Also a cumulative law of multiplication. 2 times 4 is 4 times 2. Very useful. And an associate law of multiplication. 2 times 4 times 3 is the same as 2 times 4 times 3, etc. etc. 2 times 4 is 8 times 3, 12. 2 times 12, again 24. And then we have the distributive law of multiplication over addition. And here it says that if you have something which adds up times a number, you can also write this as this number times k, so n times k, or n times k. Well, that's difficult, but if you take a look at the example, then you can see the point. 12, I can split it, 2 and 2. If I have to calculate 12 times 13, that's difficult, right? So what you do is 10 times 13 is 130, 2 times 3 times 12, that's 30. 2 times 13, that's 26, 130 plus 26, 156. I guess that that's the way that you all do your calculations when you don't have your calculator with you, right? You make it more easy. But now you know why. And you also know that this is something which has been taught wrong. Often wrong. When you were at primary school, and you should never be blamed for this fact, right? And the other thing is, you know that the Egyptians already could do this. And they could do a lot of things. Now this is ISS The Hague. You see I have examples from all over the world. And this is the elevator. Because if I talk about numbers, then the elevator is very helpful. Because the elevator has something which is special. It's a crazy elevator. And it's 5, 4, 3, 2. No. 5, 4, 3, 2, 1, 0. What is this one? -1. A crazy number, -1. Okay. And this is keep the door open. Right? So now let's take a look at the numbers that you can see. We see positive numbers. That's above the ground, right? Here in the Netherlands it's very important that you are above the ground. Where I live, it's not above the ground. I live -4, which means 4 meters below sea level. Still there is no water, right? Because we have the dikes. But just that you know. Here at the ISS, ground floor, here in Europe, 0. Below 0, -1. And you see that ISS is further developed than the Egyptians, because we have the 0, and they didn't. And then we have integers. These numbers are all integers, whole numbers. 0, 5, 4, 3, 11, 1,850,396. Whole numbers. All the other ones are fractions or decimals. Fractions is like a division. 1/3 or 1/4. 1/4 is 0.25. So it's not a whole number, right? It's in. And then the old Greek taught that all numbers could be either expressed as an integer, or as a fraction, or as 0. So it's or 1, 2, 3, 4, 5, -6, -10, 1 million. Or it was a fraction like 1/4, 1 divided by 4, or 1 divided by 5, and 0, because 0 is something which is very difficult to get in, right? These were the rational numbers, but they also had irrational numbers. These are numbers that cannot be written as a fraction. So let's take a look at what we do, right? So this is the apple. This means we have a break, but we wait until we have solved this problem with the apple. What is this called? 1/2. What is this called? 1/4, right. Then we go further. 1/8. Still further. 1/60. Still further. 1/32. Do you think that I can make this even thinner? Can I divide it? Yes, I can. Right? 1/64. 1/28. 256. 512. 1024. 1 divided by 1024. I could give everybody in ISS after the break. 10 minutes break.